In this session, I am going to solve the problems on design of gears. Here, an example problem. A set of spur gears has to transmit 30 kilowatt when the pinion rotates at 400 rpm. The gear ratio is 1:4. The permissible stresses for the pinion and the driver gear material are 130 newtons per mm square and 110 newtons per mm square respectively. Determine the A module, B face width. If the pinion has 22 teeth and face width is 12 times the module. Here the given data is the gear is to transmit power is given, that is P is equal to 30 kilowatts. So then it is converted into watts, that is 30 into 10 cube watts, and speed is given, that is 400 rpm, n is equal to 400 rpm, and the gear ratio that is in the gears there are pinion and gear. The gear ratio TP is TZ is equal to 1:4, and stresses are given for the pinion and gears. This is for the sigma P is for the pinion, that is 130 newtons per mm square, and stress for the gear is 110 newtons per mm square is given. So determine the module and face width, that is M. Module is the M, B is the face width. So if the pinion has, that is TP, so tooth on pinion is equal to 22 and face width is 12 times the module, that is B is equal to 12 module. So during the design we must remember some basic definitions. There is circular pitch P is equal to pi d by t, that is pi into d by t, where d by t is the module, then so pi into m, and module is equal to d by t. So d is the circle diameter, that is d is equal to tm. So this for the basic those are the basic definitions for the circular pitch and module. You must remember those. So here during the design of gears, so there are some basic steps involved for the design. So first step is to calculation of Lewis form factor, that is Lewis form factor YP for both pinion and gear, that is YP and YZ. After calculation of the Lewis form factor, you should calculate the strength factor, that is stress into form factor, that is sigma into Y. After calculation of the strength factor, we must decide what is the strength factors for the both gear and pinion. So the next design is based on the which has the weakest strength factor. After that we are going to apply those things in Lewis equation, that is F is equal to sigma P, Y and B, that is sigma is the tangential load, F is the tangential load, sigma is the stress, this is the circular pitch, and YB is the form factor, B is the face width. So these are the basic steps. First step is calculation of Lewis form factor, second step is strength factor, third one is application of Lewis equation. In the first step there is a empirical formula, that is, so in the first step Lewis form factors should be calculated for both pinion and gear, that is YP is equal to 0.124 minus 0.164 by TP. So is equal to, as TP is already given, that is 22 teeth, that is TP, pinion teeth, that is 22 teeth. So as per the gear ratio, TP is to TZ is equal to 1:4. Whenever so TP is equal to 22, then TZ is equal to 88, as it is a 1:4. So in this equation we are going to apply those values, that is TP and TZ. So this is for the form factor per pinion, this is the form factor per the gear. So we can calculate by using this simple formula, 0.124 minus 0.684 by TP. At the same time for gear, 0.124 minus 0.684 by TZ. By applying by substituting the values of TP as 22 and TZ as 88, so the YP, the value for form factor for pinion is 0.0929. The form factor for gear is form factor for gear is 0.1162. After completion of the first step, in the second step, calculation of strength factor for pinion and gear. So here simply we multiplying the stress into form factor, that is stress of the pinion into form factor of the pinion, that is stress is given as a 130 for pinion, 110 for gear, that is 130 into form factor 0.929 is equal to 12.077, and here for the gear stress into form factor, that is stress for the gear is 110 is given, and it is form factor is 0.1162. Here the value is 12.78. so here the value for the strength factor of pinion and gear, that is the pinion value, strength factor value for the pinion is less than the strength factor value of gear. That's why the design should be based on the pinion as its strength factor is less. So in the third step, in this step we simply application of Lewis formula, that is F is equal to, as the design is based on the pinion, the total formula is modified as F is equal to sigma P, that is the stress involved in the pinion, that is the P is the circular pitch, the formula, the basic definition, circular pitch is equal to pi m, that is pi d by t, and yp is already calculated, that is a form factor, B is the face width, it is given as a 12m. So here the only calculation involved here is F. So F is the tangential load. F is calculated as F is equal to power by velocity, power by linear velocity. Here power is given as a 30 kilowatt, 30 into 10 to the power of 10 cube watts. So V is only going to be calculated, where V is velocity formula is pi dn by 60. Here dp is the pitch circle diameter. So from the formula of module, that is m is equal to d by t, so you can write the pitch circle diameter d is equal to t into m, that is TP is tooth on pinion is already given as a 22, and m is we are going to calculate, that is 22 into m. But here there is an important step here, all the in meters, so we are going to convert this 0.22 by 1000. So in order to convert into mm, so that is 22 by 1000, that is 0.022 into mm's. So once the dp value is calculated, then you submit the d, so that you can calculate the velocity, that is pi dp into n is equal, that is pi into 0.0022 m into 400 by 60. So it is 0.4603 m. After calculation of velocity, so you can calculate the tangential load as P by V. This is the value of P. Already P is given, that is 30 into 10 cube. So once the value of F is calculated, that is 65,108 by m. So we can simply submit the values in this Lewis equation, that is 60, that is sigma P yb by yb into B, that is value of F is equal to 65,108 by m. So sigma P per the pinion, so that is the stress for the pinion is 130 is given, so that is P is equal to circular pitch, as the basic definition of circular pitch is equal to pi m, that is pi m. So next form factor for the pinion is 0.0929. So face width is given as a 12 module. So all these are, this is the m. Once the m is moved this side, this is m, this is m cube. Once the values are calculated, it is 143. So m can be calculated by cube root of 143, that is 5.2. So it can be modified as a 6. So that is m is equal to 6. Once module is calculated, you can calculate the face width as it is asked, that is B is equal to 12m, that is 12 into m is equal to 72. Thank you. Here another example on the same line, that is the design of gears. So a set of spur gears has to transmit 32 kilowatt when the pinion rotates at 400 rpm. The gear ratio is 1:4. The permissible stresses for the pinion and gear drives are 120 and 100 newtons per mm square respectively. The pinion gear has 20 teeth and its face width is 14 times the module. Compute module and face width. So here this is also same problem like the previous problem. Here power is given as a 32 kilowatts, that is kilowatts are converted into watts, that is 32 into 10 cube, and speed is given as a 400 rpm. Gear ratio is given as a 1:4, so that is TP is to TZ is equal to 1:4. As pinion and teeth and pinion is 20, then teeth and TP is equal to, so TP is equal to 20 and TZ is equal to 80. As the gear ratio is equal to 1:4, that is TZ is equal to 80. And sigma P and sigma G, this is shear stress per pinion and stress per gear is also already given as 120 and 100 newtons per mm square respectively. So the face width is given as a 14 module. So find the here also module and face width. So as the design of Spur gear involves, first step is calculation of Lewis form factor, that is YP and YG for pinion and gear, and second step is calculation of strength factor, that is sigma into Y. So based on the strength factor we select the design. So third one is the application of Lewis equation for the based on the strength factor. So here also you should remember the basic definition, that is the circular pitch P is equal to pi d by t, that is pi into d by t is the module. The basic definition for the module is equal to d by t, that is pitch circle diameter by number of teeth, that is d by t is equal to, as the d by t is equal to module, this is pi d by t is determined as a and pi m. So here pitch circle diameter also written as a d is equal to t into m. In the first step, now we are going to the first step. First step is the calculation of Lewis form factor. So here the basic formula for the form factor, that is, so for both pinion and gear, for the pinion that is 0.124 minus 0.684 by TP, as TP is given as 20, so we can submit the value as 20 here. You can obtain after calculation 0.009. So you can also calculate the Lewis form factor for the gear also by applying by submitting the value of TZ as a 80 as it is calculated. So that is, this is 0.125. After calculation of the form factors, so we are going to the strength factors. We are going to calculate the strength factors. That is, strength factor for pinion is sigma P into YP, that is 120. Sigma P is for the pinion, that is the stress of the pinion is 120 and form factor is 0.9, it is 10.9. For the gear, sigma P into YZ is calculated as 100 into 0.0115, that is 11.5. Here the Waker strength factor for the pinion is identified. So next design is based on the pinion only, as the strength factor for the pinion is less. So the equation here in the third step, we are applying the Lewis equation to the pinion. So here the formula for the F is equal tangential load is equal to stress, circular pitch, so form factor and face width. Here tangential load only is going to be calculated. Tangential load F is equal to P by V, where P is the power, that is 32 into 10 cube is given, and velocity, that is the linear velocity, is going to be calculated as V is equal to pi dn by 60, where D is equal to dP, as the design is based on the pinion. So here dP, circular pitch, that is the pitch circle diameter. From the basic formula, the basic definition of module, that is d by t, you can derive for the d is equal to t into m, that is t. T means it, as the design based on the pinion, T is taken as a TP, so TP, that is 20, and M. Here the only conversion is 20 by 1000. So in order to convert those meters into mm, that is here. So by using this pitch circle diameter, you can convert the velocity, that is, you can calculate the velocity, that is pi dpn by 60. After calculation of velocity, it is calculated as 0.4188. By submitting the value of V here, you can get the value of F as a 76,394 by M. So once the value of F is calculated, we can simply submit the value here, that is in Lewis equation, that is F is equal to sigma P. So F is calculated in terms of module. So sigma P is given. So P is the circular pitch as a Tm, that is Tp into M, and Yp is calculated. So B face width is equal to 14 M. So by using this is the M cube is equal to 160.82. So M is equal to cube root of 160.82, that is 5.43. So you can assume as a 6. Then this is the module 6 as taken, and B is the face width also calculated at B is equal to 14 times of the module, that is 14 into 6 is equal to 84. Thank you.